You see? Does everyone see that? In other words, it's the mathematical inverse. I'm just throwing in dummy numbers there, and then the inverse of this is 1 over x. So you do a command in Excel, and if you paste and copy, it'll just automatically, so as you paste, you command this to be the inverse of that cell there. And then you copy and paste, and it says yes, and so it inverts everybody. Okay, so try that out. So finally, last but not least, after you have these three, so you have zero inhibitor, MPG, MPG, you'll have these sets of data here. See them. This set. 1 over y. See it? 1 over y. 1 over z. And so on and so forth. Okay, now now that's still in results. These two tables. And again, I warn you, I repeat, I urge you, if this tube was out of order and gave you if it was jumped out of sequence, in other words, too high a number, too low a number, for whatever reason, again, it could be thermal error, for all you know. Guess what? Pull it out. Absolutely pull it. Put it in the table, yes, but then before you graph it, yank it out. Don't put it in the graph. And then the graph will look like this. The graph is these three inverse tables. What does that graph look like? It looks like this. It is 1 over V, 1 over S, right? Now watch out. This is done on, you say what, insert graph? I think insert.
Mm-hmm. Chart.
Graph?
Chart.
Chart. Thank you. You said chart. You go to scatter. And scatter will give you the following thing. You had 5. And then you right-click on the mouse, and you say, regression, yes. Yes. Show regression. It says a trend line. It says trend line, yes. You say, yes, I want a trend line. Regression, yes, I want a regression. Now, if there's something else and it says going backwards, what does that command say? How does it say that? It says extend back. So in other words, while you click on that, say regression, yes, you also want to extend it backwards. Extend, I'm not sure what the word is extend, and you say negative, and so it says, well, how much? Well, go back. These numbers are what? See that? It goes from inverse is 0.4 to, so it was, what was the inverse? We covered it up. Where'd it go? The inverse of that is about 2, 5. So go back, let's say 4. So in other words, it'll ask you, do you want us to extend it or project? Now, I forget what they're, project, extrapolate, extend, and negative. Go in the negative direction and just say 4 back. Experiment around. You'll see what I mean. Why do you want that? Because if you don't, you see, we want to see, you'll get that, yes, but you won't get this going through. And we want it to go through such that it goes all the way back here. Again, the inverse graph of that thing, like inverse of 2, well, inverse of 0.40, that is the inverse, 0.4 right here. So if you go back here, that was a 0.4 here. So you want to go back, go back to -2 over here. What did I say? 4, 2. Experiment around. You'll soon find out what we're talking about. Try 2, see what happens, and that way it'll draw the graph clear back down to here, which is what you want to see.
So you mean you want us to extend the x-axis to the negative values?
Negative direction.
Okay.
That's exactly right. You will get 3 graphs on one. You get 3. That was no inhibitor. Here it is. That's no inhibitor. No. No inhibitor. Fine. Then you'll get one with an inhibitor. That's one of the inhibitors. You know, so it looks like that. And okay, and then you'll get a third. You'll get a third. Also, that'll be above your no inhibitor line. We don't know where it's going to be. Okay? And it's off over the ceiling. Now, the question here now is this. When you do that, in your discussion, here is the crux of the issue. In your discussion, you'll come up with a good argument as to whether it appears that they're trending towards the same intercept. If they were all within error going towards that same intercept, then you would say, more or less within, here's the question, the crux of the issue is, Vmax, 1 over Vmax, which is the intercept, is about the same, plus or minus 15%. Plus or minus 15% of what? Of the regression numbers. The intercept on the regression data. So you have to show that. That's why it says, check that off. Say, yeah, show the regression. Extend, yes, extend out here so we can see it. All right? Am I making myself very clear here? Okay, so in your discussion then, you'll say the following. You'll say, you will come up with the following conclusion. You'll conclude, just on your own data, is this competitive? Yes or no? Yes or no? And you can say, I see the following trends when I get back to discussion. Some people say, yes, because within 15% error, the intercepts are all the same. They're more or less the same. Or they all trended towards the same. Maybe they met out here someplace, and you could say, well, that could have been a tube error over here. Right? If you had a tube error here, a very slight tube error, that would put, they'd all meet over here, you see. And sometimes the graph will show that. That's probably a tube concentration error, and you can probably say, well, you know, you could argue, okay, and yes, the answer is yes. Our data says yes. Now, other people with their data, they'll say, no, they don't. They're not. These two are not competitive. And then third, there's a third option here that I want you to also consider. They'll say yes on one and no on the other, because you have two inhibitors. So you'll say yes. First one, absolutely, no problem, competitive inhibitor. Next one, no, not a competitive inhibitor. I have seen some people say the following. I have seen some people say, we cannot accept or reject the hypothesis. The hypothesis is that these are potential drugs that are competitive inhibitors. If you're testing a hypothesis, we assume that all of these are competitive inhibitors and good drug candidates. And so you could say, yes, we accept that hypothesis on substrate 1. No, we reject that hypothesis on inhibitor 2. And then some people say, based upon our data, we cannot say. Insufficient. But they did a good job of reporting it. They showed all the graphs, they showed all the data, and they said insufficient. Cannot reject, cannot accept the hypothesis. Either way, we don't vote. That's real world. Sometimes you'll say, this data is just insufficient. And what you're saying is, you're saying to somebody, go back into and do it again. You know, make sure. In the real world, it doesn't happen that often because we have, don't forget, automated equipment. It's all automated pipetting. There's no pipetting errors. It's done by a robotic arm that goes along. It's all done on microtiter plates, and so the spectrophotometer errors are not there, and it's all temperature control. So it's very rare that people say we have insufficient data to accept or reject. Accept or reject. However, so I want you to commit on one or the other. And you won't lose points by saying, yeah, we reject. Look at the data. Stick by your data. Stick by your data, saying, absolutely, we will not say yes. Or absolutely can say yes on one, no on the other, or third case, no. Everyone's out. Absolutely, by our data, nothing's competitive here. Forget about it. Okay, fair enough? Great, now the first thing I want you to do is to practice all of this by running the blank. Okay, so the first thing you need to do is run the blank. The blank should contain everything except what? Enzyme.
The enzyme.
It contains no enzyme. It contains substrate. It contains buffer. And instead of enzyme, you just add water. That's all you do. Okay? Now, Rajiv, you cannot work alone. And I don't know